The cos is positive and the rest are negative.
Make it turn around and flex, make it slide in the jets. Ayy, this the beat that make it do it for a check, make it do it for the net. How you moving in your neck? Ayy, like your X-Men, you can get X'd out. I remember telling Noah we the next out. Now we looking at the charts, we the best now. Got the keys, we the best now. Ayy.
Good day. Welcome to our pages. Be it you are watching on YouTube, be it you are watching on Facebook, be it you are watching on TikTok, welcome to our pages. I hope you subscribe, like and share after watching this video. So we started the year correctly, but unfortunately, beginning of the year, we didn't start posting as yet, but now we have started with what you want. So today we are going to just start on trigonometry, grade 12. So it means that we are going to do compound angles and double angles. So before that, obviously, we need a recap on the grade 11 work. So I'm just going to do a quick recap on the grade 11 work. And then from then, we can do some questions regarding grade 11 work so that you check what you had forgotten before I can go to grade 12 work. I wish you the best and I hope that you understand this. And the book that I'm going to be using, all the questions that I'm going to be using in this section, I'll take them from the Platinum textbook. Grade 12 Platinum textbook is the one that I'm going to use. So if you have any question in any of the questions or any of the exercises in that book, you can just send any of the questions that you have. So before wasting any time, let's just get straight to it. So all these that I'm going to teach you now, they are the tools that you must understand so that you understand the whole of trigonometry. So I hope you still remember that sine of theta is equivalent to y over r, since sine of this angle is opposite over the hypotenuse. So this is the y. I hope that you still remember that. And cos of theta is x over r, since it is the adjacent over the hypotenuse, so making sense. And the tan of theta will become y over x, since it is opposite over the adjacent side. I hope you still remember that. So when you get to, after understanding this, and also don't forget to understand, obviously, the theorem of Pythagoras. You know that. The theorem of Pythagoras. So what does it state? In this right angle triangle, it states that our r squared is equal to our x squared plus our y squared. So whenever we do this in trigonometry, there's one thing that I must remind you that you must always do. If you're having a triangle, maybe we're missing x. We're having r, and just remember that r is always positive, right? So just remember that if you're in the third quadrant, your x will be negative and your y will be negative. Always remember that. After finding your final answer using theorem of Pythagoras, ask yourself, which quadrant am I dealing with? And then from then you can place the sign where it is supposed to be. And also I hope you know this, like in the first quadrant, that's what I was explaining actually, that in the first quadrant everything here it is positive and r will always be positive. So here in the second quadrant, x is negative, however y is positive. In the third quadrant, both x and y are negative. And then in the fourth quadrant, we have x that is positive but y is negative, right? So you must always remember that. So that's one thing also that you have to remember. So all things I said you must remember. The first one being the ratio to the x and y, and where they are what? Positive, where positive or negative. And the third thing that you must remember before getting to grade 12 is this table here. So what do you understand from there? We understand that if we're having any angle that is in the first quadrant, all the ratios becomes positive. So all the ratios are positive in the first quadrant. All of them, they are positive. And then in the second quadrant, so this is from 90 to 180. So if you're having any angle that is between 90 and 180, only sign of that angle will be positive. So it means that cos and tan becomes negative in this quadrant. So here in the third quadrant from 180 to 270, tan is the only one that is positive and the rest they will be negative. And then in the fourth quadrant, so it means that from 270 to 360, only cos is positive and the rest they are negative. I hope this is just simple. So let me just write this as the cast diagram. So remember the cast diagram. And then also what you must remember, it is the reduction formulas in different quadrants, right? So in quadrant 1, we just say theta, right? So the first quadrant, it is just theta, or we can just say 360 plus theta. That's when the angle is rotated and again going to the first quadrant again, right? So right now I'll first avoid talking about the reduction formula of 90 plus or 90 minus, since this will call for co-ratios. I'll explain that after this. So sine of 180 minus theta, like I was saying, 180 minus theta falls in the second quadrant. So sine will be positive and the rest will be negative. Cos and tan will be negative. And then in the third quadrant, that's 180 plus theta. So it means that sine is negative, cos is negative, but tan is positive. Since we say tan is positive in the what? In the third quadrant. And then also in the fourth quadrant, we are expecting to see that cos be positive, because we said cos is positive in the fourth quadrant. However, in the fourth quadrant, we also have another reduction formula, right? So another reduction formula that is in the fourth quadrant, besides 360 minus theta, we also have negative theta. So if you have maybe let's say cos of negative theta, we know that this angle is falling in the fourth quadrant, and in the fourth quadrant cos is positive, so this just gives us cos of theta. However, if you're having sine or tan of negative angle, we know that this falls in the fourth quadrant, and this gives us negative sine of theta. I hope that made a lot of sense. So also this, you must also remember this. And then lastly, let me talk about this now. So co-ratios. So just imagine you're having this triangle here, right? So this is theta, and then this is 90 minus theta, and this is 90 degrees, right? So if we're here at theta, if we want maybe sine of theta, we know that sine of theta becomes the opposite over the hypotenuse. So it is C over A, right? But also, if we check here on this, yes, opposite, yes, that's correct. So if we check maybe on that angle, if we have cos 90 minus theta, if we are at cos 90 minus theta, can you see now that cos is equal to adjacent over hypotenuse? So this is C over A. So what am I trying to say? I'm trying to say that cos 90 minus theta is equal to sine of theta. So these are equal. But not just only this. What do you have to take away from this? So theta and 90 minus theta, you can see that if you add theta and 90 minus theta, you get 90. So what does that tell you? It tells you that if you're having a sine of 30 degrees, it will definitely be equal to the cos of 60 degrees. Can you see that? If we add 30 and 60, you get 90. So the sine of another angle will be equal to the cos of another angle. Or the cos of 30 will be equal to the sine of 60. Or maybe if you're having a sine of 89, that will be equal to the cos of 1. Why is that so? Because 89 and 1, if you add them together, we get 90. So these are called co-ratios. So the sine of another angle and the cos of the other angle, they will be equal. So you can also guess that sine of 20 will be equals to cos of, yes, you guessed that right, cos of 70. Why? Because 70 and 20, if we add them together, we get 90. Okay, enough about that. But if we're having cos 90 minus theta, this gives us sine of theta. And sine 90 minus theta will give us cos theta. Now when we're dealing with 90 plus theta, just think about this. Just think about this Cartesian plane. So we say this is 0 to 90 to 180 to 70 and so on, right? So again, when we add angles in trigonometry, when we are going that way, that is adding angles. And when we are going that way, that is subtracting angles, that is negative. So imagine we are here at 90. If you say 90 minus theta, so it means that we are talking about the angle in the first quadrant. So it's 90 minus theta. And then when we say 90 plus theta now, we are talking about the angle that is in the second quadrant. So we must always remember that 90 plus is in the second quadrant. So what happens now? So if we are having cos of 90 plus theta, when it is cos like that, we know that it is falling in the second quadrant and cos is negative. So when cos is negative now, this will cause the sine of that angle to be negative as well, irregardless if sine is positive in the second quadrant. We know that cos is negative. So cos 90 plus theta now gives us negative sine of theta. And now sine 90 plus theta, we know that this is in the second quadrant and sine is positive. So this will make cos to be also positive, irregardless if cos is negative in the second quadrant. But just because sine 90 plus theta falls in the second quadrant, so it means that our cos will also be positive. So again, in grade 11 or previous grades, you also learned the identities. So identities. So which identities did you learn? There are only 2, but you can expand the 2 and there will be 5, right? But the main one, they're just 2. So we have the tan of theta, which is equals to sine of theta over cos of theta. So this one, we can also reciprocate that. And 1 over tan theta can give us cos theta over sine theta. We just reciprocated, right? So that is the identity number 1. So where is this useful? It is useful when you are dealing with identities and also solving equations. Working with tan is very difficult other than working with cos and sine. Again, we have this one that says cos squared theta plus sine squared theta is equals to 1. So we only have this identity and this identity, but this one can also expand. So we can also say make cos subject of the formula and this becomes 1 minus sine squared theta, or make sine subject of the formula, so sine squared theta becomes 1 minus cos squared theta, just like that. So now, like I said, they are just 2, but there will be now 5 just because we expanded some of them, right? 3, 4, 5. So these are important things that you must remember. You must always remember that before going to grade 12. And also about solving equations and general solutions, I think I'll deal with them when we are doing the grade 12 stuff. I'll get to explain how to solve equations and also how to do general solutions. So solutions. So these two are actually the same, solving equations and general solutions. They just differ just a little, and I'll explain that. So now, as I said, we just do just simple questions just to see if you still remember the grade 11 work. So I won't do everything, I'll just pick some and some so that I won't waste time on grade 11 work. If you want to watch this grade 11 explanations on trigonometry, you can just revisit our grade 11 content on trigonometry, right? So just pick some of just a bit. Maybe let's start on this first one. So on this one we are given this diagram. So always when we are given a diagram like that, you can construct like that so that you have your y and your x. So this will be your x. So here we are given that this is negative 6 and 5. So if we are given a point like that, you know that a point is made out of two things. So the x-intercept and the y-intercept. So it means that our x here it is negative 6 and our y becomes 5. So theta it is given there, you can also put it there, still the same thing, right? So now you have to find the r or the hypotenuse, right, before attempting the questions. So how can you find r now? We say r squared is equals to x squared plus y squared. So r squared becomes our x being negative 6 squared plus 5 squared. So r squared becomes 36 plus 25. So r squared becomes 61 and our r becomes root of 61. So one thing also that you must remember is that when they say solve this without using a calculator, when you have to deal with the diagram, when you get your square root like that, if it is not a perfect square, just leave it inside the square root. Don't take it out. Don't try to punch this in a calculator to find a value. They will see that you have used a calculator. However, let's continue. So they said use the diagram alongside to find the length OP, and we just found OP. So OP is root of 25. So don't forget to write OP. Don't just leave it as R. We want to answer what they asked. So OP is equals to that. So the next question they said we must write down the value of sine theta. So looking at this is where theta is, right? So what is the value of sine theta? So this is 1.2.1 and this is 1.1. So what is sine theta? We know that sine theta is equals to opposite over hypotenuse. So our sine theta becomes 5 over root of 61. And then we move to the next one. They said 61 cos squared theta plus 1. 61 cos squared theta plus 1. So this becomes 61. And then we need the cos of theta. So cos of theta, we know that cos of theta it is adjacent over hypotenuse. So this is adjacent over hypotenuse. So let's just place it like that. So adjacent is negative 6 over our hypotenuse is root of 61, right? And then they said plus 1. So this is having a squared because this is cos squared, right? So what do we do now? So it means that we are going to square this. So this becomes 61. If we square that, we are going to get 36 over 61. And then plus 1. So 61 and 61 will cancel out and we have 36 plus 1, which is 37. Simple as that. And then the next question they said find the tan of 180 minus theta. So what is 180 minus theta? We know that it is in the second quadrant, so our tan is negative, so this is negative tan theta, right? And looking at the diagram, what is the value of tan theta? So tan theta is equals to the opposite over the adjacent. So it means that our answer here, our final answer will be 5 over 6. So it will just be 5 over negative 6, which gives us negative 5 over 6, just like that. It's as simple as that. So let's see what else do we have on this question paper, or on this question, on this exercise. So here we are given that if 7 sine theta plus 4 is equals to 0. Let me just rewrite it there. We are given that if 7 sine theta plus 4 is equals to 0, and you're also given that cos is greater than 0. Without use of a calculator, solve for 1 minus 49 cos theta. It is having a square, so cos squared theta. So that is the first question. And the second question, they said cos theta multiplied by tan of theta. So these are the two questions that you have to deal with in this situation. So how do you deal with this type of question? You deal with this using a Cartesian plane. So let's start. Let's use black instead. Okay. So first, let's expand this, or let's make sine subject to the formula, right? So if we're making sine subject to the formula, so it means that we're going to take 4 that side, and it becomes negative 4, and then we divide by 7, so it will be negative 4 over 7. So it means that our sine of theta becomes negative 4 over 7. And you know that this 4, it is the opposite, and this 7 is the hypotenuse. So it means that we're going to draw a mini diagram, right? So this is negative, right? So that's the first take. This is negative. Sine theta is equal to a negative value. So we ask ourselves, what is sine negative? Sine is negative in the 4th quadrant and in the 3rd quadrant, right? And then the next step, you look at the other restriction that they gave you. So they said cos of theta must be greater than 0, right? So where is cos greater than 0? So cos is greater than 0. Being greater than 0 means being positive. So cos is positive in the 1st and in the 4th quadrant. So it means that our diagram is going to come from the 4th diagram. So it means that we are going to draw our diagram in the 4th quadrant. And we're going to place our theta there. And then sine of theta, we said it is opposite over hypotenuse. So this becomes negative 4 over 7. So now what's left is to find the value of x, and using the theorem of Pythagoras. Like I said, the theorem of Pythagoras is very, very important. So we can say our r squared is equal to our x squared plus y squared. So now what is the value of our r now? Our r is 7, so this becomes 7 squared, being equivalent to x squared plus negative 4 squared. So this gives us 49. 49 minus 16 is equals to x squared. So what is 49 minus 16? That's 33, right? So x squared is equals to 33. So square root, so x becomes root of 33. So we can place it there. So this is root of 33, just like that, right? So the next step now, it is to solve what they asked for. So let's see what they asked for so that we can solve. So the first question, they said 1 minus 49 cos squared theta. So answer becomes 1 minus 49 and then cos squared theta. So what is the value of cos? Cos is adjacent over the hypotenuse, right? Adjacent over the hypotenuse. So our adjacent is root of 33 over 7, and this is being squared. So this is 1 minus 49, and then if we square this, we are going to get 33 over 49. So now 49 and 49 may cancel out, and our final answer becomes 1 minus 33, which is negative 32. And then the second question said cos theta multiplied by tan theta. So cos of theta multiplied by tan of theta. So if you want, you can just simplify tan of theta. So this becomes cos of theta multiplied by sine of theta over cos of theta. So cos and cos may cancel. So our answer is in sine of theta. So what is the value of sine of theta when looking at this? It is negative 4 over 7. That's how you can solve that. So let's get back to this question. Let's see what else can you do. What else can you do? Maybe prove the following identity. Maybe let's just do this and also simplify, and we can call it a day. Or maybe let's just do one identity. Let's just do 4.1. So 4.1, they say prove that cos squared x plus sine x cos x multiplied by tan x is equals to 1. So I think we can just choose the side that is better to work with, right? So the left hand side, it is complicated. So our left hand side becomes cos squared x plus sine x, and then we're having cos x. I said it's better to first change tan because tan is hard to work with. So this will be sine x over cos x. So here we can see already that these things are multiplying each other. So cos and cos may cancel each other, and sine x multiplied by sine x. So this gives us cos squared x plus sine squared x. So what do we know about this? This is an identity that we did previously. So this is equals to 1. So after this, you must conclude by saying, therefore, left hand side is equals to right hand side, and then you are done. And then I said we will do one on simplify. So let's simplify the first one, 5.1. So 5.1, what do we do on 5.1? So we can see that this is 2 sine 90 minus x. So 90 minus x, we know that it calls for cos. So this gives us 2 cos of x minus cos 360 minus x. This falls in the fourth quadrant. So in the fourth quadrant, cos is positive. So this becomes cos of x. And then this one is saying 2 cos 90 plus x. Like we explained that 90 plus x falls in the second quadrant and cos is negative. But since we use the reduction formula of 90, it will change into sine. So this becomes 2 and then negative sine of x. And then minus. So this is 180 plus x, which is in the third quadrant, and sine is negative. So this becomes negative sine of x. So now we can continue. So 2 cos x minus cos x, this just gives us cos of x. So yeah, and then here this will be negative 2 sine x, and here we have minus and minus giving us a positive sine x. So this becomes cos of x, and then negative 2 sine x plus sine x gives us negative sine x. But we can see this cos x over sine x, we know that this is 1 over tan, so this becomes negative 1 over tan of x, just like that. So let's see which other questions can we do here. Okay, I think we can also do this one. So this one also, you draw a diagram, but this one doesn't really matter if you don't use a Cartesian plane, because this one doesn't have another restriction, so anything is positive, right? So let's see. So tan 38 is equals to k. So since this doesn't have a denominator, we'll put our own denominator, or the denominator that we know that each and every number carries. So it will be over 1. So what do we know about tan of any angle? We know that it's equals to the opposite over the adjacent. So k is our opposite and 1 is our adjacent. So we draw a diagram. So this is our diagram. So we're going to put 38 there, and then this is our 90 there. So now we ask ourselves, like, which other angle can we add to 38 to get 90? And it is 42. Is it 52? Yes, it is 52. So this is 52 degrees. So tan of this angle is equal to the opposite, which is k, adjacent, which is 1. So now we can find the hypotenuse using the theorem of Pythagoras. So r squared is equal to x squared plus y squared. So r squared becomes 1 squared plus k squared. So our r now becomes the square root of all that, so which will be 1 plus k squared. And you cannot find the square root of that, so we just place it the way it is. So it is 1 plus k squared. So now let's solve for this. Tan of 142. So this is the same as saying tan of 180 minus 38. So this thing falls, 180 minus 38 falls in the second quadrant. So this becomes negative tan of 38. And when we're 38, what is the value of tan? K over 1. So our answer becomes negative k over 1, which is just negative k. And then let's move to cos of negative 38. So we said that the cos of a negative value means that it is falling in the fourth quadrant. So this becomes just cos of 38. And then we check here. What is the cos of 38? We know that cos is adjacent over hypotenuse. So this just gives us 1 over the root of 1 plus k squared. And then we are done. And then sine of 52. So sine of 52. So we know that the sine of this angle here is equal to the opposite over the hypotenuse. So this also gives us 1 over 1 plus k squared, just like that. So yes, this is how we solve this. So maybe let me also solve this one with the angles. I think when they give you this type of question in the exam, it is worth more like 7 or 8 marks depending on what has to be done. So let's just do it. 7.1. So 7.1, it is saying that It is saying that sine of 150 multiplied by sine 55 multiplied by sine 135 multiplied by tan 240 all over cos 330 cos of 145 tan of 150 and cos 225. So let's simplify each and every ratio one by one. So we start on sine there. So we know that that is over 90, so it's in the second quadrant, so let's reduce that. So this becomes sine 180 minus 30. We do it a step at a time, and then sine 55, we cannot simplify that further, so this is just sine 55. Sine 135, this becomes sine 180 minus 45, and then tan 240 is equal to tan 180 plus 60. So this all over cos 330, we know that this becomes cos of 360 minus 30. Cos 145, this is cos of 180 minus 180 minus 35. Tan 150, this is tan of 180 minus 30, and lastly cos 225, this is cos 180 plus 45. Right, so what do we do next? So sine 180 minus 30, this is in the second quadrant, sine is positive, so this becomes sine of 30. Sine 55 doesn't have a special angle, and we didn't reduce this. And sine of 180 minus 45, still in the second quadrant, this becomes positive sine 45. Tan 180 plus 60 is in the third quadrant, and tan is positive, so this becomes tan of 60. And then this is in the fourth quadrant, cos is positive, so it's just cos of 30. And then this falls now in the second quadrant, cos is negative, so it becomes negative cos of 35. And lastly, the second quadrant, tan is negative, so negative tan of 30, and then cos, it was cos what? 180 plus 45 is in the third quadrant, cos is negative, so it becomes negative cos 45. So let's simplify that further. So sine of 30, we know that it is equivalent to half, but sine of 55 we don't know, so let's just leave it like that for now. And then sine of 45, it is root of 2 over 2. And then the tan of 60, what does the tan of 60 give us? It's root of 3. So this is root of 3. And then cos of 30, it is root of 3 over 2. And this one, it is negative. So at least let's cancel one negative with another negative, right? So cos 35, it doesn't have a special angle, so let's just write it as cos 35. And then tan of 30, it is root of 3 over 3. And then lastly, what do we have? Okay, that was tan of 30, and then cos of negative, so this gives us negative root of 2 over 2. So before finishing it off, let's just check what is equal the top and bottom. So we can see that sine of 55 is equals to cos of 35. Like we explained, these are co-ratios, so they're equal. We can cancel them out. Root of 2 with this root of 2 over 2, they'll cancel out, right? So we'll be left with at least a half multiplied by this, so it will just give us half root of 3, right? Or we can just write it in this way. We can just write it as root of 3 over 2, right? So root of 3 over 2 now, what do we do next now? We know that it is being divided by what? It is being divided by root of 3 over 2, and then being multiplied by root of 3 over 3, being multiplied, oh, there's nothing to multiply else. So let's just finish that off. So we know that this will be root of 3 over 2, and root of 3 multiplied by root of 3, it will just give us 3, and 2 multiplied by 3 gives us 6. So now we're going to have root of 3 over 2 times, since there's divide there, so it will be times 6 over 3. So this 1, this 3 and 3 and 3, they'll cancel out, and our answer will be just root of 3, just like that. Yes, I just hope that you enjoyed this session with me. I really enjoyed. So like I said, the general solution and the solving of the equations, I'm going to do them while you are doing the grade 12 work. So after this, I'm going to come up with the double and compound angles in the next session. Please don't forget to subscribe, follow, like, and share.